Hello, my name is Radhika Naliving. Today I will explain about chapter 1, which is about the basic energy system. This chapter explains how our body produces energy to allow our muscle to move during physical activity. Energy and ATP, all the muscles movement required energy. This energy comes from a molecule called ATP, which stands for adenosine triphosphate. ATP is produced when the body breaks down the food we eat. When the last prophase born in ATP is broken, energy is released for muscle contraction. Fuel source in the body. There are three main fuel sources in the body, which are carbohydrate, fat, and protein. Carbohydrates are the main source of energy during exercise. Fat are mainly used during rest and low intensity activity. Protein are not a main energy source, but they help with body growth and repair. The three energy system. The body has three main energy system. Each energy system work depending on the intensity and duration of the activity. The first system is ATP PCR system, also known as elastic anaerobic system. This system does not require oxygen and provide energy very quickly. It can only last for about 10 to 15 seconds. This system is used during explosive activities such as sprinting, jumping, and weightlifting. After using this system, the body needs several minutes to fully recover. The second system is the glycolytic system, also known the lactic anaerobic system. This system does not use oxygen and break down glucose or glycogen to produce energy. Lactic acid is produced as a byproduct, which can cause muscle fatigue. This system can supply energy for about 2 to 3 minutes. It is commonly used in activities such as the 400-meter sprint. The third system is aerobic system. This system requires oxygen to produce energy. It produces energy at a slower rate but can last for a long time. This system is mainly used in long distance activities such as running, cycling, and swimming. Lactic acid is formed when there is not enough oxygen in the muscle. The increase in acidity causes muscle to feel tired and weak. Lactic can be transferred to the other muscle or the liver to be reused as energy. The energy system used by the body depends on the duration and intensity of the activity. High intensity and short duration activity mainly use anaerobic system. Low intensity and long duration activity mainly use the aerobic system. In conclusion, the body does not rely on the only one energy system at a time. All three energy systems work together, but one system will dominate depending on the activity. Understanding energy system help us improve sport performance and training. Hello, this is about topic chapter 2, body respond to the exercise. In this chapter, we learn how the body respond to the exercise. This response can be acute, meaning they happen immediately, and or chronic, meaning a long-term adaptation that develop after regular training. Metabolic response, prolonged exercise. Doing prolonged exercise that lasts more than 10 minutes, the body mainly uses aerobic metabolism to produce energy. Oxygen uptake reaches a steady state. But in hard condition or very high intensity, oxygen uptake continue to drift upward. In very short instant activity, the ATP-PC system provides energy for the first 10 seconds. When the exercise lasts more than 20 seconds, anaerobic glycolysis becomes the main system. If the activity continues for more than 60 seconds, the aerobic system becomes more dominant. Doing incremental exercise, oxygen uptake increase in a linear pattern. When VO2 max is reached, oxygen consumption stop increasing even if the workload becomes heavier. Overall, metabolic response include increased fuel usage, increased oxygen consumption, and more metabolic byproducts such as lactate and carbon dioxide. Heart rate, cardiovascular response. Heart rate increase as exercise intensity increase. Doing submaximal oxygen doing submaximal exercise, heart rate reach a steady rate. Individual with the better fitness has a lower steady state heart rate. Doing maximal effort, heart rate reaches its maximum value. Stroke volume, which is the amount of blood pumped per beat, increase until above 40 to 60% of maximum heart rate. After that, it plateaus. Stroke volume increase because there is more venous return, stronger heart contraction, and the lower resistance in the blood vessel. Trained individuals usually have a higher stroke volume. Cardiac output increases together with the exercise intensity. When the stroke volume reaches a plateau, increase in the cardiac output comes mainly from a higher heart rate. Doing prolonged or hard exercise, cardiovascular drift occur, where heart rate rises, stroke volume fall, but cardiac output stays stable. Systolic blood pressure increases with the intensity, while diastolic blood pressure stays the same or slightly decrease. Resistant training can cause very large increase in the blood pressure. During exercise, blood flow is distributed so that more blood goes to the active muscle. Up to 18% of the blood flow can be direct to walking muscle. Blood vessels dilate at the active area and constrict in the inactive area. As a intensity increase, the muscle inject more oxygen, causing the large difference between arterial and venous oxygen. Plasma volume decrease during exercise because of the sweating and fluid shape, which can affect performance. Blood pH become more acidic during intense exercise because of the accumulation of lactate. Respiratory response. Before exercise start, breathing hard increase due to anticipation. During exercise, ventilation increase because of the higher carbon dioxide, more hydrogen ion, higher body temperature, and the signal from the muscle and joint. At the low intensity, tidal volume increase. At the high intensity, breathing hard also increase. After exercise, breathing will slow down during a recovery as the movement stops and carbon dioxide level drop. What is the breathing problem? Dyspnea is shortness of breath caused by weak respiratory muscle. Hyperventilation occurs when ventilation is higher than the body need the oxygen. The Valsalva maneuver, which involves holding the breath during heavy lifting, can be dangerous because it reduces cardiac output. In conclusion, exercise causes major metabolic, cardiovascular, and respiratory changes that help the body produce more energy, deliver more oxygen, and remove waste product during physical activity. Okay, so that's all. So, bye.